Okay, for problem number 8c, we have another function that we need to find the critical numbers of, and therefore our intervals of increase and decrease. And our function is 2 cosine theta minus sine squared theta. So in this function, notice that we have trig functions, we don't have an interval. So that tells us that our answers are always going to be in general forms, because this is going to be any rotation of the unit circle. So first, as always, we need to take our derivative and find k prime. So k prime, we're just doing our derivative here. These are just derivatives that you need to know, obviously. Derivative of cosine is negative sine. This is going to be negative 2 sine theta. The derivative of sine squared, you need to use the chain rule. So the derivative of anything squared is 2 times that. But then we have to multiply by the derivative of the inside, which is sine theta, which is cosine theta. So our derivative is right here, negative 2 sine theta plus 2 sine theta cosine theta. So to find critical numbers, we need to set this equal to 0. Now we don't have to worry about the undefined case in this problem because sine theta and cosine theta are never undefined. But what we can do is factor out a 2 sine theta. And if we factor out 2 sine theta, what we would have remaining is just negative 1 plus cosine theta, which you could rewrite as cosine theta minus 1. So here's our derivative fully factored. And again, we want it to equal 0 to find our critical numbers. So now we need to think about when each of these terms could be 0. Well, sine theta is 0 every time theta is a multiple of pi. 0, pi, 2 pi, 3 pi, negative 2 pi. Any of those numbers and sine theta would equal 0. So we could say n pi. And for cosine theta minus 1 equals 0 when cosine theta is equal to 1. So remember, cosine is the x-coordinate. So cosine is only equal to 1 when we're at the far right side of the unit circle. So if we're on our unit circle, cosine is equal to 1 right here only, which is 0, but it's also 2 pi, or negative 2 pi, or any multiple of 2 pi. So what I'm getting at here is theta, we have here is n pi, or we have here is essentially 2n pi. So we're saying any multiple of pi makes this 0, and any multiple of 2 pi makes this 0. But since these are not distinct things, n pi includes all of these. So really this is kind of redundant, and we only need this one. Again, because essentially think of it like 0, if you plug in theta equals 0, it makes this term 0 and this term 0. So we don't really need to count it twice. We're just saying anything that's a multiple of pi, whether it's an even multiple or an odd multiple, that will make this product 0 in some way. So these are all our critical numbers. Our critical numbers is any multiple of pi. So now we need to think about a number line. So since this is a trig function and it's in general form, this is going to be something that's very repetitive. So we only need to think about a couple of scenarios here. So I'm just going to put 0, pi, 2 pi, negative pi, negative 2 pi on here. We don't really need that many. We'll see a pattern happen really fast, but I'm just putting those just for good measure here. So these are all our critical numbers, all these multiples of pi. And remember, when you write n pi, you're saying n is an integer in order for that to work out. So to find our intervals of increase and decrease, we would just need to plug numbers in between those critical numbers. So when we plug in any number, let's say, to make it easy, in between 0 and pi, we'd choose pi over 2. Well, one thing you can notice is cosine theta minus 1, that's always going to be negative, because cosine theta can only be in between negative 1 and 1. So if you have a number that's in between negative 1 and 1, and you subtract 1, the highest it could be is 0, but it only is 0 on these points that are already on here, because that's what we found. We found the critical numbers when it's 0. If it's not 0, it has to be negative, because if you're any other number between -1 and 1 and you subtract 1, it's a negative number. So this term is always negative, so I don't need to keep checking that for all of these. Pi over 2, if I plug it in here, sine of pi over 2 is 1. So that's positive, but I'm multiplying by a negative, so I get negative for that interval. But what if I plugged in the next one? In between pi and 2 pi, I could plug in 3 pi over 2. Again, I'm picking numbers that are easy because they're just the axes of the unit circle. 3 pi over 2 is straight down. Well, if I'm picking 3 pi over 2, sine now is negative. And this, like we said, is always negative. So I get negative times negative, which is positive. And you can check by just plugging in a couple other ones or just thinking about how the unit circle repeats and see that this is going to be complete alternation. It's going to be a very easy pattern. Just alternates pluses and minuses. So therefore, we're almost done. We just need to write our intervals of increase and decrease. So first, our critical numbers were just any multiple of pi, n pi, where n is an integer. We need to write our intervals of increase. So increase is any time we're going from an odd multiple of pi to an even multiple of pi. So what we can say here is we could say our intervals of increase are from odd to even. How do we do that? You would say that's from 2n minus 1 pi to 2n pi. So 2n is always an even number, no matter what integer you plug in, and 2n minus 1 is always an odd number. So this way I'm saying for a given n, this is the odd to the even. That's increasing. So decreasing is when we go from even to odd, like 0 to 1, or -2 to -1. So decreasing, we're going from even to odd. So we would go from any 2n pi to 2n minus 1 pi. So our increasing intervals are any interval that's from starting at an odd multiple of pi and going to an even. That would be increasing. Our decreasing is any time we go from an even to an odd, we get a decreasing interval. So those are our critical numbers, and those are our intervals of increase and decrease.
The Teaching Center, UF's Learning Resource Center.